It asks us to convert the following quadratic function from vertex form to standard form. Okay, standard form, if you guys will look back up here, this is your standard form where you have the vertex form here. So what we're going to need to do is we need to multiply this out, and then we're going to add like terms on some things. So as a little side note, remember this, but this is where I told you guys you're going to add -3 plus 3. This is the shortcut. Plus -3, that gives us -6, and then -3 times -3 gives us 9. So basically what this comes out to be is it comes out to be x squared minus 6x plus 9. Distribute the -2. Long time since we've done this, so it may be a little you may be a little rusty on this. Okay, so now what you're going to do is you're going to distribute this -2 to all three of these terms. So you should have -2x squared plus 12x minus 18 minus 2. Terms are like terms, so I can go a step further and say -2x squared minus 12x minus 20. And that's our answer, because now it's in our standard form that we wanted. Alright. A population of frogs increases at an annual rate of 22%. How many frogs will there be in 5 years? Okay, there's that formula that I told y'all you're going to have memorized. In this case, when we use B, we did a worksheet on this where we talked about growth and decay. Here, since the frogs are increasing, we should know that that's a growth. So we're going to say A is our initial amount, which is 100, times B, which is our rate, or 1 plus our rate. And we're adding because it's growth. We needed the growth. And our decimal, so remember you have to move this guy over twice. So 0.22. And we're going to write that to the x power. Remember I told y'all that sometimes they like you to go a step further, and they like you to write. They like you to actually add these two numbers together. But either way, despite which one you choose, it's going to give you the same answer. I'm going to put in the second one. So NY1, I'm going to type in 100 times 1.22 raised to the x power. And it wants after 5 years. So I'm going to go to second graph, and I'm going to go to 5. Roughly 270. So there's going to be about 270 frogs when we're done. Alright, so on this one, we're using the same formula, but we're going to have to again decide whether it's growth or decay. So here, mouse population is 25,000 and is decreasing in size at a rate of 20 per year. What is the mouse population after 3 years? Okay, so because it's saying decreasing, we should know that we want the decay, so we're subtracting. So our initial amount is 25,000 times our B, which is 1 minus, and again we have to move this 2 places, so we have 0.20 to the x power. Tell y'all that they do like to have you subtract these. If you were to subtract them, you get 0.8. Some of you guys aren't believing me despite me being the math teacher. Y'all are doubting my math abilities. So there it is. And yes, there are extra zeros because I have it in float, but that's okay. Regardless, it's 0.8. Alright, so now we're going to put this in the calculator. We're going to type in that number. This time it wants after 3 years. So I'm going to go to second graph. I'm going to go to 3 years. And that is roughly 12,800 mice. Alright, number 6. Give an example of the following types of correlation coefficients. Okay, so basically you can give any number between I would say anything less than 0.3 would be a weak. Could be a strong 0.8, 0.9. The closer it is to 1, the stronger it is. The further away it is from 1, the weaker it is. So on this one, since it wants a negative, you want a negative number in front of it. So you could say negative 0.2. Again, the closer it is to to 0, the weaker it is. Or the further away from 1 it is, the weaker it is, depending on the way you want to see it. Okay, and a strong negative would be like 0.8. The closer it is to a -1, the stronger it is.